Hey everyone, welcome back to ReMathable. Today we are going to address the topic of polygons, discuss how to calculate interior and exterior angles, also discuss the differentiation between regular and irregular polygons. However, if you are a bit unsure about what polygons even are, or like what makes a polygon regular or irregular, don't worry. You can click on the thumbnail right here on the screen to watch our Intro to Polygons video first. It's got everything you need to get started. But for those who did watch it, let's do a super quick recap before we dive into angles. So remember, polygons are closed shapes made of straight lines, and each one has a different number of sides, right? So a polygon is a two-dimensional figure made up of straight lines. So as already stated, different polygons have different number of sides. A triangle has 3 sides. So n is equals to 3, where n is the number of sides. A quadrilateral has 4 sides. A pentagon has 5 sides. Hexagon has 6. Heptagon has 7. Octagon has 8 sides. A nonagon has 9 sides, and a decagon has 10 sides. We will be using this n, the number of sides, to help us calculate both interior and exterior angles today. So grab your notebooks and get ready to solve some technical questions of polygons. Okay, so before I get into the details, I want to clarify what an interior angle is and what an exterior angle is. So angles contained inside a shape are known as the interior angles, okay? So all these angles in green are interior angles. Let's label these lowercase a, b, c, d, and e, okay? So a, b, c, d, and e are interior angles. What are exterior angles? Exterior angles are the angles outside the shape. Okay, so see, the uppercase A, uppercase letters, uppercase B, uppercase C, uppercase D, and uppercase E. So all the uppercase letters are the exterior angles of this pentagon. Okay, can you see a relationship between the interior and exterior angles of a polygon? So they lie on a straight line. So the exterior and interior angle, from the looks of the diagram, they should add up to 180 degrees. And that is the case, okay? So interior angle plus an exterior angle is equal to 180 degrees. So this is the first relationship that we can derive from this figure. Okay. Now, tell me, how many of you know what the sum of the interior angles of a triangle is? So what is the sum of the interior angles of a triangle? I'm sure all of us know that all the angles sum up to 180 degrees, right? What about a square? So the sum of the interior angles of a square is 360 degrees. It is 360 degrees for any quadrilateral, whether it's a square, parallelogram, pentagon, rhombus, kite. So any quadrilateral, and the sum of the angles, sum of the interior angles of a quadrilateral will be 360 degrees. Now, these were simpler shapes. What about shapes? So, for example, if the question asks you to find the sum of the interior angles of a shape with 32 sides, luckily we have a formula that we can utilize in order to find the sum of the interior angles. So, the sum of the interior angles of a polygon with n sides is n minus 2 into 180. Okay, so if n can be any number, okay, so if n is 3, so in case of a triangle, the value of n is 3. So 3 minus 2 into 180 gives us 1 into 180. So it is 180 indeed. Okay, let's check it for in case of a quadrilateral. So if n is 4, a quadrilateral, what is the sum of the interior angles? So 2 into 180 is equals to 360 degrees, as we already know. So we can use this formula to calculate the sum of the interior angles of a polygon. Please keep in mind that this formula gives you the sum. It adds up all the interior angles and gives you the sum of the interior angles. Okay. What about the sum of exterior angles? So remember that the sum of exterior angles is 360 degrees irrespective of the value of n. Okay, so the sum of exterior angles of all polygons is 360 degrees. So the sum of interior angle is dependent on the value of n, while the sum of the exterior angles is 360 degrees always. Now, if the question asks you to find the value of one interior angle, but before getting into that, we need to understand the difference between a regular polygon and an irregular polygon. So as already discussed in the video about basic polygons, the thumbnail of which was shared in the start, for a regular polygon, all sides have the same length. all interior angles are equal. All exterior angles are equal, or they're the same. Okay. While in case of irregular polygons, the sides are not of the same length. The angles are also different, and therefore each exterior angle is also of a different value. Okay, now keep in mind that whether we have a regular polygon or an irregular polygon, the formula for calculating the sum of the interior angles is going to be n-2 into 180. And the sum of exterior angles will be 360 degrees. Okay, so what I mean by this is that, for example, if you have an irregular quadrilateral and a regular quadrilateral, so this is a square, the sum of the interior angles of this quadrilateral, which is an irregular one, will be 360 degrees. We substitute the value of n as 4. So 4 minus 2 is 2. 2 into 180 is 360 degrees. So the sum of the interior angle of this irregular polygon is going to be 360 degrees. And it is going to be 360 degrees for this regular quadrilateral as well. Okay, so the sum is going to be the same, irrespective of the fact that whether the polygon is a regular polygon or an irregular polygon. Okay, the difference is that for a regular polygon, all angles are equal, right? So what we do is that we divide the total sum, the sum of the interior angles, by the number of sides, because we want to divide this sum equally between all the angles. Right, so 360 divided by 4 gives us 90. So each interior angle of a square will be 90 degrees. Right, so what we do is that we divide the sum by the number of sides, and we get the size of one interior angle of a regular polygon. Okay, this does not apply in case of an irregular polygon, because here each individual interior angle will be of a different value. So let's write this down. So the value of one interior angle is going to be n-2 into 180 divided by n. Okay, so this is the value of one interior angle of a regular polygon. And since it's a regular polygon, all interior angles will be equal to this value. Just like interior angles, the sum of exterior angles will also be equally divided between the number of sides or number of angles of the polygon. So each exterior angle is going to be sum, which is 360, always for exterior angles, divided by the number of sides. Okay, so these formulas will be used to calculate individual interior or exterior angles for regular polygons only. Okay, let's try and put this to use, put these concepts to use in some past paper questions. Okay, so the shaded region M shows part of a regular pentagon. So here you need to first focus on the word regular. which means that all sides and all angles are equal. And then you should know that a pentagon has 5 sides, so n is going to be 5 in case of a pentagon. And the shaded region n shows part of a regular octagon. Again, regular means all sides and angles will be equal, and octagon means that n is going to be 8. So an octagon has 8 sides. They're asking you to calculate the value of x. So they have told us that M is a regular pentagon. Using this information, we can calculate the interior angle of the pentagon. Let's first do that, okay? So interior angle of M is going to be n minus 2 into 180 divided by n, because it is a regular polygon. So what do we have when we substitute values? 5 minus 2 into 180 divided by 5. So 5 minus 2 is 3. 3 into 180 is 540 divided by 5. So the value of each interior angle of a regular pentagon is 108 degrees. Okay, so this is 108 degrees. Now let's calculate the interior angle of the regular pentagon. So we need to find the value of x, right? How we're going to do that is that we're first going to find the interior angle of the regular pentagon. Then we're going to find the interior angle of the regular octagon. And finally, we're going to add these two together and subtract them from 360, because see, this is a complete turn. So we're going to subtract these two interior angles from 360, and that is going to give us the value of x. Okay, so let's calculate the interior angle of n. So it's n minus 2 into 180 divided by n, and we know that the value of n is 8. So 8 minus 2 into 180 divided by 8. 8 minus 2 is 6. 6 into 180 is 0. 1080 divided by 8, which is 135 degrees. Okay, so the interior angle of n is 135. Now we know that since this is a complete circle, so 108 plus 135 plus x should be equal to 360 degrees. So x is 360 degrees minus 108 degrees minus 135 degrees, which is 360 minus 243 degrees, 117 degrees. So the value of x is 117 degrees. Okay, so the diagram shows a quadrilateral and a part of a regular octagon. Okay, so you're going to highlight regular here. Octagon means n is equals to 8. Quadrilateral means n is equals to 4. But see that they've not specified that the quadrilateral is a regular quadrilateral. So this means that these angles will be of different value. While in case of the octagon, since it is regular, all the interior angles would be equal. And since they've given us the value of one interior angle, which is 135 degrees, all the interior angles would be 135 degrees. Okay, because it is a regular octagon, all angles will be equal, all sides will be equal. Now, what is the question asking us to do? Form an equation in x and solve it to find x. Okay, so we have three angles. Two of them are in terms of x. If we can calculate this angle, which we can, why? Because the angles on a straight line add up to 180. So 180 minus 135 degrees will give us this angle, which is going to be 45. Okay, so now we know that the sum of angles in a quadrilateral, is 360 degrees. If you're not sure, you can use this formula to calculate the sum of interior angles. In case of a quadrilateral, the value of n is 4. So 2 into 180 degree gives you 360 degrees. So we know that the sum of the interior angles, so 45 plus 3x plus 103 plus x plus 20, should be equal to 360 degrees. So let's write this down in order to form an equation in x. So 45 plus 3x plus 103 degrees plus x plus 20 degrees should be equal to 360. Let's simplify by collecting like terms together. So 3x plus x is 4x plus 45 plus 103 plus 20 is 168 degrees. So this is an equation in x, and let's solve it to find the value of x. So 4x is equals to 192 degrees, x is equals to 48 degrees. So x is equals to 48 degrees. Hopefully, working through these past paper questions has helped you put the theory into practice and given you more confidence in calculating interior and exterior angles. But remember, understanding these rules is just the first step. The real magic happens when you apply what you've learned to solve real exam-style questions or problems. So keep practicing, stay curious, and don't be afraid to make mistakes. Every question that you solve is a step closer to mastering the topic. Also, if you found this helpful, please don't forget to like, subscribe, and check out the other videos in our IGCSE O Level stream for even more math support. Until next time, stay focused, keep learning, and believe in your progress.